Okay, 2.3 notes. We're doing Introduction to Matrices. So here we go. We're going to name the dimensions of a matrix and we're going to do simple operations of a matrix. Here we go. So a matrix is a set of rows and columns used to organize data. So to name the dimensions of a matrix, it's rows by columns. You never actually multiply, but that's just how it is written. So rows run in this direction. So in this case, there's a row here and a row here. Columns go up and down. So there are these columns here. So for the dimensions of this example, there are 2 rows by 3 columns. So we would call this a 2 by 3 matrix. Equal matrices are when each relative number is the same. So notice in every location the numbers match, so you can say these matrices are equal. Adding matrices is when you add each relative number. Matrices must be the same size in order to add them. So in this case, we're going to do the first number plus the first number to get the first number over here. So 1 plus 5 is 6. And then 2 plus 6 makes 8. Moving on to the bottom row, 3 plus 7 is 10, and 4 plus 8 is 12. Notice if they weren't the same size, it wouldn't make sense to add them. Subtracting, same thing. You're just subtracting each relative number, and they must be the same size. It's usually a little bit harder to subtract because it's dealing with negatives. So 1 minus 5 is negative 4. 2 minus 6 is negative 4. 3 minus 7 is negative 4. And 4 minus 8 is negative 4. Make sure you have your matrix bracket around that. All right, scalar multiplication is when you multiply each relative number by a value. In this case, we're multiplying by 1/3, which is the same as dividing by 3. So I'm going to divide each of these numbers by 3. So 1/3 of 6 is 2, 1/3 of 12 is 4, 1/3 of negative 9 is negative 3, and 1/3 of negative 18 is negative 6. So number 1 says to state the dimensions of the matrix. So how many rows by columns does this have? So this has 1 row and it has 3 up and down columns. So this is a 1 by 3. For part B, this has 3 rows going this way and only 1 column going up and down. So it's a 3 by 1. You try C. All right, hopefully you've got 2 rows by 3 columns. Try D. Okay, this one has 3 rows by 2 columns. All right, so it says to find the values of x, y, and z for which the matrix equation is true. Notice that we have an equal sign in between. That means the first number in the matrix will equal the first number in the matrix. So that would mean if I divide by 3, x is 3. The second number in the matrix should equal the second number in the matrix, so y equals x. Well, notice x is 3, so if you substitute that in for x over here, that means y is 3. The last number should equal the last number, so negative z equals 8. Z is not by itself, so I have to divide by negative 1, so z equals negative 8. Okay, number 3, it says to find the values of x and y for which the matrix equation is true. So then this is, again, equal. So y equals 2x minus 6. I cannot solve that because I don't know x or y. I have 2 variables. So that means I'm going to go to the matrix again and see x equals 2y. Now I have a system of equations that I can solve for x or y. To me, substitution makes the most sense because I have y by itself or x by itself. It doesn't matter which direction you plug it in. In this case, I'm going to plug this value into the x of the first equation. And so I get y equals 2 times, the x goes away, it becomes 2y, and then minus 6. So when I simplify, I get y equals 4y minus 6. And then from here, I can subtract over the 4y, giving me a negative 3y equals negative 6. And then divide by negative 3, I'm going to get y equals 2. So I found y, but I still have to find x. So you're going to plug this in, going circle to circle. So x equals 2 times y is 2. So x equals 4. And then you're done. This is solved by system of equations, but it's not an actual system. So you don't have to write it as 4, 2 as a point. But if you do, I won't mark it wrong. You can leave it separate as x is 4, y is 2. Number 4 says to find the following if. So we're adding matrix A and matrix B. So here we go. Negative 2 plus negative 6 would make negative 8. 0 plus 7 is 7. 1 plus negative 1 is 0. Bottom row. 0 plus 4 is 4. 5 plus negative 3 is 2. And negative 8 plus 10 is 2. So that's it. For part B, we're going to subtract A minus B. So if you go negative 2 minus negative 6, this is tricky. So negative 2 minus negative 6. Remember, when you minus a negative, it becomes plus. So it's actually negative 2 plus 6, which is going to be 4. 0 minus 7 is negative 7. 1 minus negative 1 becomes plus 1, so 1 plus 1 is 2. 0 minus 4 is negative 4. 5 minus negative 3 becomes plus 3, so 8. And then negative 8 minus 10 is negative 18. For part C, we're adding matrix A and matrix C. Notice the sizes of the matrix don't match, so this one is not possible. All right, for number 5, we're going to determine if the order you subtract the matrices matters. So go ahead, subtract A minus B, and then do B minus A, and tell me if order matters. Yes or no? Okay, hopefully you see that these are not equal. They're actually opposites of each other. So when you go 11 minus negative 4, and get 15, it's different than going negative 4 minus 11 to get negative 15. So the order in which you subtract does matter. Okay, number 6, this is multiplying by the number 3 to matrix A. So all of these are going to get multiplied by 3. So negative 4 times 3 is negative 12. 1 times 3 is 3. Negative 1 times 3 is negative 3. Your second row, 3 times 3 is 9. 7 times 3 is 21. 0 times 3 is 0. Bottom row, negative 3 times 3 is negative 9. Negative 1 times 3 is negative 3. And 8 times 3 is 24. All right, for part B, we're going to multiply everything by a negative. There's a hidden 1. So if I multiply everything by negative 1, it's just going to become the opposite. So positive 4, negative 1, positive 1. Negative 3, negative 7, 0, 3, 1, negative 8. Okay, number 7, we're going to use PEMDAS with matrices, believe it or not. So inside the parentheses, we're going to add these up first, and then we're going to end by multiplying by the 2 in front. So let's add the matrices in the parentheses. I have 1 plus negative 4, that's negative 3. Negative 2 plus 5 is 3. 0 plus 6 is 6, and 3 plus negative 8 is negative 5. Now that I've condensed this, I can multiply everything by 2. So that would give me 2 times negative 3 is negative 6, 2 times 3 is positive 6, 2 times 6 is 12, and 2 times negative 5 is negative 10. All right, for part B, I'm going to multiply this by 5. So that's going to get me 5 times 0 is 0, 5 times negative 1 is negative 5, and 5 times 4 is 20. This is where it gets a little tricky. You can either change and multiply everything by negative 2, or drop the minus down and multiply everything by positive 2. Both of those work. So if I do a change, that means I'm going to add, and then a negative 2 times all of this would give me a positive 6, a negative 2, and a negative 4. Hopefully that makes sense. So then I can add these matrices. So 0 plus 6 is 6. Negative 5 plus negative 2 is negative 7. And 20 plus negative 4 is 16. And that is it.